Hi, this is your lucky sir. Ionic equilibrium worksheet we are doing. Aqueous solution of potassium alum. Potash alum is K2SO4, Al2SO4 taken thrice, 24 water. Potassium sulfate is made up of strong acid and strong base, so no hydrolysis. But aluminum sulfate is made up of strong acid sulfuric acid and weak base aluminum hydroxide. So whatever the ions are coming from weak, they are responsible for the hydrolysis reaction. So here it is aluminum plus 3. The hydrolysis constant of ammonium acetate. Ammonium acetate is a salt of weak base ammonium hydroxide, weak acid acetic acid. So when both are weak, KH is equals to KW by KA into KB. Aqueous solution of KCl is neutral because it is made up of strong acid and strong base. So it is wrong option, this is wrong option, it is wrong option, no hydrolysis. The pH of 0.1 m solution of the following compounds increases in the order. This is interesting. See, NaCN is made up of weak acid, strong base. NH4Cl is made up of weak base, strong acid. NaCl is made up of strong acid, strong base, so pH is equals to 7. HCl is strong acid, so pH is close to 0 or 1. So HCl should be minimum. Then weak acid case, then both strong. Sorry, here is strong acid case, weak base. Here both are strong, and here weak acid, strong base. Above 7, exactly 7, below 7, close to 0 or 1. Nature of 0.1 m solution of sodium bisulfate is NaHSO4. Still, it can release one proton, so you can say this is acidic in nature. The number of hydroxyl ions produced by one molecule of Na2CO3 on hydrolysis is Na2CO3 on hydrolysis produces 2 moles of NaOH and 2 moles of 1 mole of H2CO3. 1 mole of H2CO3 can produce 2H plus. The aqueous solution of CH3COONA is alkaline in nature, right? Because it is made up of strong base. So this is right statement. Acetate ion undergoes anionic hydrolysis. Exactly. The weak part undergoes hydrolysis, and the hydrolysis reaction is CH3COO minus plus water. CH3COOH plus OH minus. Due to the formation of this OH minus, that is alkaline in nature. Both are right and correct explanation. Aqueous solution of ZnSO4 is neutral. No, wrong. Because zinc is weak base, sulfuric acid is strong. So this is neutral is wrong. This is acidic. So statement 1 wrong. Salt of strong acid and strong base does not undergo hydrolysis is right. So option 4. Option 4 will be, it is wrong statement, it is right statement. Aqueous solution of ammonium acetate is neutral. Again, ammonium acetate is made up of weak acid, weak base. Weak acid, weak base pH will be almost to 7. You can say neutral. Very close, 7.01, 7.02, 6.98, like that. Dissociation constants NH4OH and that of CH3COH are nearly equal. That's why it is same. So both are right and correct explanation. Aqueous solution of Na2CO3 shows pH is greater than 7. True, because this is made up of weak acid and strong base. So pH 7 is right. Salt of strong base and weak acid undergoes anionic hydrolysis. Weak acid and strong base. Example, you can take Na2CO3. In that CO3 minus 2 undergoes hydrolysis to form H2CO3 plus OH minus. Because of this OH minus, that is alkaline in nature and pH is more than 7. So exactly correct both statements and correct explanation. Common ion effect and solubility product based questions. Dissociation of CH3COOH is suppressed by CH3COOH dissociates like CH3COO minus and H plus. So if you add H plus, it is done. If you add H plus, it is done. If you add CH3COO minus, it is done. So any of these can be used. Any of these, if you are adding, the reaction goes backward. That means CH3COH dissociation is suppressed. Ionization of NH4OH is suppressed by the addition of NH4Cl because NH4OH dissociates like NH4 plus and OH minus. When you are adding NH4Cl, a strong electrolyte which gives 100% NH4 plus and Cl minus due to the excess of ammonium ions. Ammonium ions concentration is increased here. Because of that, this backward reaction is favored. So dissociation of NH4OH is suppressed. So of the common ion effect of NH4 plus ion. The solubility product of the electrolyte of the type A2B3. S is the solubility. A2B3. It is 108 S to the power of 5. 72 is not there for any. 108 S to the power of 2 is not there. It is also not there. For AB, you can remember simply S square. For AB2, 4S cube. For A2B3, it is 108 S to the power of 5. For AB3, it is 27 S to the power of 4. We are going to get this repeatedly. For the electrolyte type A2B or AB2, Ksp is equal to 4S cube. So S is equals to Ksp by 4 to the power of 1 by 3. Okay, this is cube root. The solubility of calcium phosphate, Ca3PO4 taken twice. So this is A3B2 type. Okay, now so 108 S to the power of 5. At a certain temperature, the solubility of the salt MmAn in water is S moles per liter. The solubility product of the salt is, okay, now this you need to write like this: m to the power m, n to the power n, s to the power m plus n. Just now we have written A2B3, AB3 in that way. If you calculate, you can make a simplified equation like this. Why only As plus 3 gets precipitated as As to S3, not Zn plus 2 as Zns when H2S is passed through an acidic solution containing Al plus 3, As plus 3 and Zn plus 2. This is practical inorganic chemistry based question. What we are going to do in the laboratory. That is because solubility product of As to S3 is less than that of Zns. Remember, when solubility product is and ionic product, if you see comparison, if ionic product is more, precipitation takes place. If solubility product is more than ionic product, soluble. Solubility product of AS2S3 is less than that of ZNS. So easily it can be precipitated. In qualitative analysis, to identify the second A group sulfides, HCl is added to salt solution before the addition of H2S because, okay, we don't need much sulfide concentration. We need to decrease the sulfide ion concentration. H2S dissociates like 2H plus plus S minus 2. Its dissociation can be suppressed by adding HCl due to the increase in the concentration of H plus ions. So S minus 2 concentration also decreases because the backward reaction takes place in HTS, dissociation case. So low S minus 2 ion concentration is required. How do we differentiate between Fe plus 3 and Cr plus 3 in group 3? This is again qualitative analysis. Okay. Fe plus 3 and Cr plus 3 by decreasing OH minus ion concentration. For that purpose, we need qualitative analysis. Both these belong to group 3. Okay, we are going to add NH for OH and NH for Cl. The addition of NaCl and to AgCl decreases the solubility of AgCl because ionic product exceeds the Ksp value. When ionic product is more than the Ksp value, definitely solubility will be decreased. Okay, NaCl contains sodium and chloride ions, AgCl contains chloride ion. So similar type of ions are there, chloride ions, and because of that, the ionic product exceeds the Ksp value. Chloride concentration is increased now. When Ksp ionic product is more, precipitation is not easily done. Ionic product, if it is more than solubility product, precipitation. Solubility product, if it is more than ionic product, soluble. In this case, you are increasing the chloride concentration, so ionic product is more than the Ksp value, so solubility decreases. Out of calcium plus 2, Al plus 3, Bi plus 3 and Mg plus 2, NH4Cl and aqueous ammonia will precipitate. This is the reagent for group 3. IIT 1991. Okay, now these questions are very common now. So Al plus 3 and bismuth plus 3. You need here the qualitative analysis that we will do in inorganic chemistry almost in the ending of this year. Which pair will show common ion effect? Common ion, NH4, NH4. Don't take for strong. Here both are strong, so no use. Strong, no use. AgC and KCl. Okay, now both are salts. Here also KCl, here also KCl. We need 100% dissociation type. So NH4OH and NH4C. 100% dissociation should be done for the strong electrode that you are adding. Thank you. This is your lucky sir.